In this video, we're going to be looking at the two ways that plywood is attached to the top plates in the various seismic retrofit guidelines. We're going to be looking at the history behind these differences, and we're going to take a look and see which one of the two is the best way to do it. So this first way to do it, we see here in Standard Plan A. You see how here at the nails, we have the nails up here at the top, and we also have nails here down at the bottom. Now this is all the way along the plywood. You see the nailing of the upper top plate and the lower top plate all along here. Now we see this in a few different guidelines, and we're going to look at every one of those in the rest of this video. So if you come over here, this is from this is another way to do it. This is from chapter A3 of the International Existing Building Code, and you see right here there's the nails in the upper top plate only. Right here, this section right here, that is the lower top plate at the bottom, and this is the upper top plate. So you see there's absolutely no nails right here in the lower top plate. So we're going to look at both ways of doing it and see which one is the best. Right now we're going to look at every single building code and seismic retrofit guideline until December of 2020, which is right now. So everything that was published before now, we're going to be looking at this particular connection, the plywood to top plate connection. This is the first instance I'm aware of where there was a construction detail that showed nailing of plywood in an official document. This comes from the guidelines for the seismic retrofit of existing buildings, published, I believe, by the Structural Engineers Association of Southern California in the early 90s, quite some time ago. I was given a copy when I went there for a seminar in the mid-90s. So what they had, the main thing here is we see that the 8 penny nails, 4 inches on center on the edges of each individual piece. So that means each piece of plywood will be nailed like this. And the really critical thing here that is important to know is this edge nailing right here. You see how these little dots right here, there's a dot here, a dot here, a dot here. All those little dots, that all represents edge nailing onto the plywood. So that's the edge of the plywood, just like it says right here, all edges of each individual piece of plywood. Now there's two top plates here. There's the upper top plate right here, and then there's a lower top plate right here, and all the nails go into the upper top plate. This is from the 2015 Special Design Provisions for Wind and Seismic, and this is an American Wood Council publication, and it is a part of the building code for the entire country. So anything that applies here applies to all new construction. So this is the basis of new construction in the building code. And let me show you what it tells us here. So here we have the nailing along all the edges, just like we saw a little while ago. Here at the bottom, we also see the nailing at the bottom. It's spaced, 6 inches apart, 4 inches apart, whatever. Main thing is it's here at the bottom. And then when you come over here, you have nailing again at the upper top plate. Remember, this is the lower top plate. This is the upper top plate. Now, if you want to stagger the nails, that's fine too. So you can go into the upper top plate. Here's a nail here, here's a nail here, here's a nail here. And those can be spaced, whatever, let's say just 4 inches on center. But you can't put it here. So you can't come here and put one in, 4 inches over here and put one in, 4 inches up here and put one in, 4 inches come here. And that's what we're going to be looking at. That is the way Standard Plan A and some other guidelines do it, and it is in contradiction to what is in the special design provisions for wind and seismic. So historically, this is the next retrofit guideline that came into existence in Los Angeles. And again, you can see it has 8 common nails at 4 inches on center at sheathing edges. OC stands for on center or apart. And sheathing is the same thing as plywood. So again, this was intended to resist 380 pounds of earthquake force for each linear foot of plywood, just like we saw previously. This is from the City of Seattle retrofit guideline. And you can see here we have the exact same thing. We have the edge nailing along the upper top plate here and the upper top plate here. Even though it doesn't, I don't show that here, the nailing pattern here again is at 8D commons at 4 inches on center, just like the other guidelines. So this actually took the information from the original precedent of the California Existing Building Code guidelines for retrofit existing buildings and made a new drawing, which I think is much better. It's much clearer because it shows the upper and the lower top plate and the way it was nailed. It also shows the shear transfer ties. And the shear transfer ties, notice the shear transfer ties, the nails that go into the shear transfer ties in this direction down that way into the upper top plate, they only go into the upper top plate, which is why these nails here are only going into the upper top plate as well. So this framing anchor, also called a shear transfer tie, is connected to the upper top plate, and the plywood is also connected to the upper top plate. And we're going to see the reason for that when we actually take a look at the standard Plan A detail. Many people may not be aware of this, but the hardware manufacturer Simpson Strong-Tie also has a plan set, and it is just like all the other ones. As you can see, we have 8D common nails at 4 inches on center on all edges of each individual piece of plywood, and all the nailing is on the upper top plate. Again, this is to resist 180 pounds of earthquake force for each linear foot of plywood. This is from the City of Portland retrofit guidelines, and this construction detail is not very clear, and it was actually lifted from the Los Angeles retrofit guidelines, but it shows the exact same things. We have 8D common nails at 4 inches on center at the sheathing edges, and so this again is a plywood pattern, nailing pattern that is supposed to resist 380 pounds of earthquake force for each linear foot of plywood. So this is from FEMA P-1100. That's the most recent retrofit guidelines from 2019. And then you can see that the nailing is only in the upper top plate. So this plywood nailing is just like it was for the guidelines for seismic retrofit of existing buildings that was published in the 70s or so. So we've gone back about 50 years to the way it originally came out and the way Jim Russell actually originally intended these plywood nailing to be. So you can see it very clear here. It says provide all required nailing at upper top plate, and you see the nails right across here along the upper top plate very clearly. There are a few nails here at the bottom. There's one here at this lower top plate, one here, one here. It certainly won't hurt, but they're not required. So anyway, what you see here is what Jim Russell originally intended for standard Plan A. So as you probably noticed, all the retrofit guidelines ultimately referred back to Jim Russell's original work in the guidelines for the seismic retrofit of existing buildings as far as the plywood nailing goes. They all recommend 15/32 plywood. They recommend 8D nails. They recommend 4 inches on center on the nailing, and they recommend nailing into the upper top plate only. And the shear walls can resist 380 pounds per linear foot. Standard Plan A decided to change all of that. And let me show you how. You see here where it says 4-inch staggered spacing typical. That means you go here, 4 inches later you go here into the upper top plate, 4 inches later you go into the lower top plate, 4 inches over you go into the upper top plate, etc. So what you end up with is you end up with the edge nailing as being 8 inches. So we have 8 inches here to here, 8 inches here to here, 8 inches here to here. And when you only have 8-inch edge nailing, the capacity of the shear wall drops down to 190 pounds per linear foot. So remember earlier we saw that the plywood is all nailed at 380 pounds if you put them 4 inches on center on the edges. Well, in this case, they're only 190 pounds, which is a whole lot weaker. Let me show you exactly why that's a problem. Let me show you why it's such a problem. So this is, again, our upper top plate, and then this is our lower top plate. And you see how these are 4 inches apart along each plate. So here we have one, and then we have one right here. That's 4 inches, and we have one here. That's 4 inches, 4 inches, 4 inches. So in effect, along the entire upper top plate, you have a nail that's every 8 inches. Now the building code does not even have a table that recognizes shear walls that are nailed on the edges at, every 8 inches. But anyway, that's what we got. So the way it would actually work is, this is a floor joist. And a floor joist is a part of the floor. It supports the floor you walk on. And what happens is when this slides this way, we want to keep that from sliding. So what we do is we take this piece of metal right here, it's called a shear transfer tie, and we nail it to the joist right here, and then we nail it down here into the upper top plate. Now the upper top plate is only 2 inches thick, or 1.5 inches, usually 2 inches. The nails that come in here are 1.5 inches. So all the nails go into this upper top plate. So what that means is earthquake force comes this way, pushes on the shear transfer tie, that goes into the nails that again are only 1.5 inches. So that force goes into the upper top plate, it pushes it that way. Then that force goes into the nails that are also in the upper top plate. And then eventually, when this piece of plywood pushes on the top like that, the bottom of it also pushes that way into the bolts. So these nails here on the lower top plate, they're not connected to the shear transfer tie, therefore they are not doing anything. So anyway, that is the problem with standard plan A. Here's a good comparison for the two types of nailing. On the left, you see what you would find if you use the special design provisions for wind and seismic and the guidelines for seismic retrofit of existing buildings and so many other guidelines that we looked at. On the right, you'll see standard plan A and 2 other guidelines that are mixed up with that. Let's see what happens when we apply these nailing patterns to a standard plan A retrofit. This table right here is from standard plan A, and it tells us that if a house is 1,200 square feet, it's heavy construction, it needs 20 linear feet of plywood on each side. Now if it's nailed 4 inches apart on edges with 10 penny nails as intended, we need 20 linear feet of plywood. Now that is 4 inches on center on the upper top plate, as Jim Russell intended, as the special design provisions of wind and seismic recommends it's done, City of Los Angeles, all those different guidelines that we looked at. If those are used, so we have 4-inch nailing on the upper top plate, we need 20 linear feet on each side because standard plan A was designed around a 380 pound per linear foot plywood nailing. On the other hand, if we use standard plan A system, where it's nailed inches apart with 8 penny nails as required by standard plan A, we need 40 linear feet on each side. So just as we saw, 8 penny nailing, 8 inches apart on the upper top plate alone only provides 190 pounds of earthquake resistance per linear foot, and therefore we need twice as much. So we need 40 linear feet on each side, which gets pretty expensive. Here we see 2 identical floor plans for 1,200 square foot houses that are considered heavy according to standard plan A. Now the one on the left will be nailing in the upper top plate only, as we saw in all the guidelines that we just looked at. And then on the right, we'll be nailing in the upper and lower top plates, just like we saw in standard plan A. Now this is what happens when we do that. When we have the 380 pounds per linear foot nailing, we only need 20 linear feet of plywood on each side. So we had 20 feet here, 20 feet here, 20 feet here, and 20 feet here. So just 20 feet on each side for a total of 80 linear feet. Now if we nail into the upper and lower top plates, then we need 40 linear feet, because remember, when we do that, the plywood can only resist 190 pounds per linear foot. So here we need 40 feet, here we need 40 feet, here we need 40 feet, here we need 40 feet. And as you can see, in order to meet the requirements that standard plan A has defined for us, we'll need to add, approximately 20 linear feet of extra foundation over here. So clearly this system does not work. So the other guideline where we find the double top plate nailing is in FEMA DR-4193. And as you can see here at the upper top plate, we have a nail every 8 inches. In the lower top plate, we have the exact same thing. So overall, the edge nailing is every 8 inches on this piece of plywood right here. Real reason why this was even considered is because of Standard Plan A. Standard Plan A was a precedent. It's kind of like case law. Standard Plan A had been, in their mind, had already been hashed out. A bunch of people had been, talked about it a whole bunch, and they finally figured out that this double top plate nailing was a good idea. And that's why it's allowed here in FEMA 4193. Says that this effort would not have been possible without prior development of the following documents: Standard Plan A, Residential Seismic Strengthening Plan. So that is why we find this in FEMA 4193. It wouldn't be there otherwise. So then the real question is, well, where did it come in Standard Plan A? And what you see, continually is that a certain standard will influence the development of another standard, which is what it should do. And in this case, Standard Plan A was influenced by another document, but it was not a code document. It was not even a government document, and we'll see what that is. So this is the final case where I could find nailing in the upper and the lower top plates. This comes from the Simpson Strong Tie catalog. This detail was in their publication from 2007 that was for homeowners for the retrofitting of their homes. So this must have been used by the people who are putting Standard Plan A together, because there's no other way that they could have come up with this. There's just nowhere, you don't find it anywhere. There's no code references. There's not in the California Existing Building Code, not in the Los Angeles Building Code. There's no precedent for it. So the only explanation I have is that. And the interesting thing is, I do recall at one of the meetings where the building official from San Leandro had talked about how he had hired someone who worked for Simpson Strong Tie, making their drawings like this for them. So either that particular person had already drawn a detail like this, or he was fully aware of it and would have also had a tendency to draw the detail like this. So that's why this detail is in Standard Plan A, and it's the only time you ever find it. And actually, it's a little bit on the crazy side, because if you think about it, this was not put in because of any engineering expertise. When you get down to P-1100, where there is some true engineering expertise, as well as what Jim Russell's original design back in the guidelines for retrofit of existing buildings and the California Existing Building Code, those are all rational. But this one, it just came about because of some quirk, some human error. And this is just to show that even though it looks like scientists with white coats and microscopes and things, or they're writing codes and things like that, it's just human beings. And sometimes things like this just happen. This is one of the most unique nailing patterns I've seen while doing this research. And in this one, it has the nailing at the bottom plate only. So this comes from this document right here, Seismic Behavior of Level and Step Cripple Walls. And that was a $7 million project financed by the Federal Emergency Management Agency. And one thing I noticed right away is these weren't engineers, they're not contractors, they don't know anything about nail guns, probably give them a hammer and they hit themselves in the head. So anyway, these people, they didn't really understand what they were doing, and they, anyway, the government gave them a whole bunch of money to come up with this construction detail, and it's an interesting one. So here, if you come over here, there's our upper top and our lower top plate, and as you can see, all the nailing is here in this lower top plate only. The other thing that's weird here is this is called field nailing right here. Field nailing is supposed to be every 12 inches, so this should probably have 3 nails only, and they ended up putting them, it looks like every 6 inches. So that's obviously a guy who doesn't worry about nail cost or have a good understanding of what retrofit shear walls are all about. The fact that you stuck it out with me probably means you don't have a whole lot to do with your time, or you're just really into this sort of thing. I wish I'd seen this sort of thing when I was younger. But anyway, we looked at all the different guidelines to see about the different ways of nailing. Some say nail in the upper top plate, some nail in both top plates, somebody says nail only in the lower top plate. And I hope I've convinced you that all the nailing should be done in the upper top plate, and the other ways of doing things should be ignored. I think it's important to remember why this is such a crucial issue. Is when you have that upper and lower top plate nailing, the shear walls are only half strength. And for example, Standard Plan A uses these, and Standard Plan A is used all throughout the Bay Area. Every building department knows about it. Every contractor knows about it. City of Oakland finances them. Berkeley finances them. California Earthquake Authority finances them. So the Standard Plan A retrofits are all over the place, and as we can see, they're going to be half strength. And then there's the FEMA one. Hardly anyone's used that, so it's not a big deal. And then finally, the Simpson Strong Tie catalog. That is of some concern because homeowners use it, and also people aren't aware of this, but we see these plans from engineers all the time. And what engineers do is you think that they've got their calculators out and they're looking at all these fancy tables, and they're not. What they do is they look at the Simpson catalog, it's got a drawing on it, and they just slop it onto their plans. And they take the hardware that's in the Simpson catalog, and then they put that in their plans, and they charge you $4,000 or $5,000 just to cut and paste the whole thing. So you will see this in plans from engineers as well. So it's still a serious concern that this lower top plate nailing is out there. Now, the one that's really weird to me is the lower top plate only. That was from a project, $7 million project, consortium of universities and research and earthquake education. Goes back like 20 years ago, and they spent $7 million for a guy to put that drawing together. But anyway, none of that matters at this point. We're just trying to make things better, trying to make sure you do a better retrofit in the future, and that you understand how top plates work. And I'm sorry we had to go through every single guideline. I just really wanted to make a point and reinforce the fact that the upper top plate nailing is so important.